And that's 6? Number 6? Okay. So let's take a look at number 6 real quick, using ratios. An entrepreneur wants to rent a billboard at least 30 feet tall to display an advertisement for her business. She is 5 foot 6 inches tall and casts a shadow 7 feet long. At the same time, the billboard casts a shadow that is 35 feet long. Is the billboard tall enough? Now, is there a diagram that's prepared for us?
Yeah.
So let's become artists. Okay. So we've got this person. She's here. Shadow, which is 7 feet long. Now, this person is 5 foot 6 inches, right? That'll come into play in a second. But then we have this billboard. Okay. That casts a 35-foot shadow. We want to know she needs a billboard at least 30 feet tall to do her display. Right? Needs to be 30 feet off the ground. I guess that's what we're looking at here. Now, is that billboard tall enough? That's what we're looking for here. There's my X. So if I'm thinking about these two triangles, everybody see the two triangles that we've created here? So now creating my two triangles, I can see some similar some proportions that I can create. Can somebody tell me the proportion that I can create? Nate.
You can just make it simple and put 5.5 over 7
is equal to
x over 35.
Yeah. Now, where did we get the 5.5? Remember that 6 inches, 5 foot 6 inches is not 5.6. Close. But it's not 5.6 because inches is out of 12 inches in a foot. So we've got to take 6 out of 12, and 6 out of 12 is 0.5. So now we cross multiply and divide. 7x is equal to 5.5 times 35. And that gets me 192.5. And when we divide by 7, I get 27.5. So, is this billboard what she needs? No, because it needs to be 30 feet tall, and it actually is only 27.5 feet tall, so we can say definitively, no, this billboard's not going to work. What other questions? Yeah? Number 5. Same type of thing here, right? Okay, a repairman needs to climb to the top of a building. He takes his measurements as shown. So we create our two triangles here. We see them in the diagram. I don't need to change any sort of dimension because I've only got feet and I don't have any inches here. I'm good. So what proportion did you create?
I did.
That's x.
6 over 4.
Is equal to?
X over.
Which is good. 6 over 4 is equal to x over 16. So 16 times 6 gets us our, come on now, 6 times 16 gets us our 96 is equal to 4x. And when I divide by 4, I get 24. So the height of the building is 24. Can he use his 28-foot ladder?
Yes.
Yeah, he doesn't even need to go all the way out on his ladder. Because the building is only 24 feet tall, and I've got a 28-foot ladder, so I can definitely use the ladder to get to the top of the building. That makes sense? Any other questions on the homework? Okay, let's do the, yeah, go ahead.
7 or 8.
7 or 8, you pick.
8.
8, got it. Using the table shows sales, right? Thank you.
What is that?
Oh, it's for tiles. The table shows sales. Now, remember that I told you to use sales made as it related to sales attempted, right? Sales made as compared to sales attempted. So that's the ratio that we're going to look at. That's the rate that we're going to look at. So let's look at person A. Sales made is 109. And I said sales made to attempted, right? Let me just jump back here.
I thought it was attempted.
Or was it attempt? See, that's what I'm going to look at. Let me see what I
did. Attempted to make.
What did I do on the key?
I don't know. I have a photo of
That's-
them.
I did made per attempted on the
I did
key.
attempted to make.
Now, we should get the same exact thing, same conclusion in the end. Like we should say, no matter how we calculate it, that salesman A is better. Does that make sense? Like, so whether I did attempted to made or made to attempted, sales made to sales attempted 167. So this is going to get me 109 divided by 167. This is 0.65. And person B made 97 sales but attempted 163. So 97 out of 163 gets us 0.59. 0.595. So we can say person B made less sales per attempt. Does that make sense?
I kind of have to.
And you had it flipped around,
Well,
right?
I have 1.53.
Which is fine. These
1.68.
right. These numbers would be different, but then the conclusion would be the same. Yeah. So person B, because person B's number was bigger when you did sales attempted versus made, that means he was less efficient, right? He had to make more attempts for every one sale made. Does that make sense?
So on the test, do you need to know, like in this situation, is the points you get based off your conclusion or based off the math?
Both. But I'll make it very clear. Like in the directions, it is not clear. I had to tell you. I'll make it very clear what the expectation is, like what the question I'm asking. All right, let's get to the warm up real quick. Cross multiply, right? So we take 2 times 15, 3 times x. We divide by 3. We get 10 is equal to x. Number 2 here, 3 times 48 gets us 144 is equal to 9 times x or 9x. We divide by 9 and we get 16. I really hope those are quick and easy problems because we'll do a lot of proportions throughout the year, a lot of solving proportions. So hopefully that's a really quick and easy thing to do. All right. So let's take a look at the notes for today, shall we? Now, I'm telling you right now, today's a difficult day. We're going to do a kind of difficult topic today. Now, let me remind you, have we already taken our chapter 1 test? Yes. Will section 1.3 be included on any one of our assessments that we have in this class? No. Now, will we use some of it along the way? Sure. But am I going to test specifically on section 1.3? No. So that should ease your mind a little bit. Now, the problem is that these types of questions that we're going to talk about today, I have seen these questions on OST tests. Okay? Now, if these actually show up there, I hope you remember at least a little bit about today. But the good thing is that this relates directly to science class. This relates directly to science class. The next thing, I should have passed these both out at the same time. The next thing that's going to be coming around is your official reference sheet for the state test. Now, you'll get one for the state test, like if this isn't the exact copy of that. But it'll be nice in color, it'll be green, I think. But this is the reference sheet that you will get on your state test. And I'm going to talk through this as well. So let me first start off by handing these out to you. I would strongly encourage you to keep this paper. Okay? Keep this paper safe. This is, I don't want to have to keep making copies of this, and I'm sure I will reference this back throughout the rest of the year because this, again, is your reference sheet for the state test. So make sure that you keep this safe somewhere in your binder, okay? If you ever need extra copies of this, I'm planning on having them like up in the blue bin up there. I'm just gonna keep them stocked. Okay. So let's kind of examine what we have here. Now, this first portion of it, the top half of the front, that's what we're going to be using today. Today is all about unit conversion. Today is all about unit conversion. Miles to kilometers, inches to centimeters, pounds to ounces, cups to pints, pints to gallons, those types of things. Meters per second to miles per hour, those types of things. That's all we're going to do today. Okay, and it's right here on your reference sheet. For everybody watching along at home, this top half is what I'm talking about today. Now, does your reference sheet change when you get to geometry? No. So that's why the second portion of the front is on there. You will not use this whole year. That trigonometry portion, you will not even understand it until you get to geometry next year. Okay, so just bypass that, flip it over onto the back. Now, on the back, you have area and volume formulas. That we are not really going to use a lot this year either. But they're there for you if you need them. Again, more for geometry. Okay, you do a little bit more volume, area, perimeter, that kind of thing in geometry. But the bottom of the back, we will use a little bit later on. We will definitely use a little bit later on. We talked about the distance formula. We talked about the quadratic formula. We're talking about some probability as well. But again, what we're going to be focusing on here is the top of the front page. Okay, the top of the front page. Now, I am sure that you know a lot of these conversions already in your head. Okay? Does anybody know how many feet are in a mile? Gio?
3,100 and 5,200. 5,205.
Wow, you were way off, man. You were way off. 5,280. 5,280. You were in the thousands. You're getting close. But that's on the reference sheet. That's on the reference sheet. Then, how many inches in a foot? 12. That's on the reference sheet. How many feet are in a yard? That's in the reference sheet. But then there are some not really well-known ones. Like 1 mile is 1,760 yards. Or 1 mile is 1.609 kilometers. Or 1 inch is 2.54 centimeters. And then we got some weight ones down the middle. A pound is 16 ounces, but a pound is also 0.45 kilograms. And a kilogram is 2.2 pounds. And then we also have these fluid ones as well. It's like when you're cooking. 1 cup is 8 fluid ounces. 1 pint is 2 cups. 1 quart is 2 pints. 1 gallon is 4 quarts. If I say gallon man, how many of you know what I'm talking about? That's the way I learned it when I was in, I don't know, whenever we learned this. Okay? I always learned it this way. Actually, you know what? I learned this picture too. I had a big G for 1 gallon. And within the G, 4 Q's.
And then inside you have little P's.
And then inside, how many pints are in a quart? 2 pints in a quart, right? Yeah. 2 P's here. And then I didn't make it big enough. Because then you got to put 4 C's inside the, yeah. So, little zoom in. Inside the pint is 4 cups, right? I don't know why, that's the way I was taught when I was a kid. That diagram. Now, does everybody know this? No. Does everybody know gallon man? No. But what's the great equalizer? This reference sheet. So you may know other conversions. Like based on this diagram, you can see that, 2, 4, 6, 8 pints are in a gallon. Based on this diagram, 4 quarts are in a gallon. Based on this diagram, if I've got 4 of all those, 4, 8, I can figure out how many cups in a gallon as well. But you know what we all have? This reference sheet. So this is what, I'm going to stick to this conversion. Okay, I'm going to stick to these conversions. Another thing yes, question.
On here it says 2 cups for 1 pint, but up there you put 4 cups for 1 pint.
Oh, I'm sorry. I must have drawn it wrong then.
I was right.
Oh, I'm sorry. I'm sorry. That's right. Only 2 C's go in there, isn't that? Yeah, there we go. See, that's why I don't use that. That's why I want to stick to this. But, and another thing that you guys have used a lot in science classes. This thing. K, H, D, D, C, M. Do you guys know what I'm referring to?
Yeah, but we have an extended version where the great King Henry died.
Oh, the great. Oh.
Yeah. 12 instead of 6.
Tara Giga. Yeah. So this is what most of you guys know. Okay, I don't know what acronym you use, but if I'm transferring from like meters to millimeters, like if I have 1 meter, how many millimeters are in that meter? Move the decimal place 3 zeros, 1,000. If I've got 1 kilometer, how many meters in that kilometer? How many meters in that kilometer? 1,000 meters in a kilometer. Now, you may be thinking,
You said like the first D to the M, and then like the K to the M. That would be million. Because it's 6 places and 6.
You're thinking all the way down to here?
Yeah.
That would be millimeters.
Oh.
Millimeters in a
I'm
kilometer.
talking about the other one.
So, but again, I'm going to try to reference that a little bit. So that should be in our brains from science class, but I'm going to try to stick to the reference sheet as much as possible. Just a fair warning, we're going to get through 1, 2, and 3 on our top portion. Then I'm going to skip to the bottom and then the back. So let's get to it. Let's convert to 4.8 gallons to fluid ounces. Now, this is the way I work with these problems. Your science teachers, they do it a little differently. I don't know offhand what they use or how they do conversions. But I remember doing this in earth science. I remember doing this in biology. I remember doing this in chemistry a ton. Converting units. Okay, so I've got 4.8 gallons. Now, start to the very left of your workspace here, and we're going to write 4.8 gallons. And I want you to always label your pieces. So write 4.8 gallons. You want to just write the G, you want to write GAL, you want to write GALS, you. So this is 4.8 gallons. And then we are going to multiply by what's called a conversion factor. We're going to multiply by a conversion factor. Basically, I'm going to multiply by one of these things on our reference sheet. Okay, now, do I have gallons to fluid ounces on my reference sheet? No. Okay, so I've got to find gallons in another way. But I have gallons to quarts. So let's use that conversion. Gallons to quarts. Now, I have 1 gallon is 4 quarts, right? 1 gallon is 4 quarts from the reference sheet. 1 gallon is 4 quarts. So I'm going to put 1 gallon down below, and there's a reason I'm putting down below, and I'll show you in a second, to 4 quarts. 1 gallon is 4 quarts. If you want to just abbreviate it, QTS, whatever, that's fine. Or just Q, whatever. Now, why am I putting it down below? Because I want the labels to cancel out. And if the labels are truly going to cancel out, they need to be diagonal from each other. Okay? If the label's going to cancel out, you want them to be diagonally from each other. I'm not going to put an equal sign because am I at fluid ounces yet? So let's keep it rolling. Let's keep going. Okay, I've got quarts now. You know that? Oh, that's speed run, man. You know that too? Yeah. No. Hold on, I need to write your pen. Okay, now, am I at fluid ounces yet? No. So I need to keep going. I'm only at quarts. Well, what's the only thing I have with quarts on it? 1 quart is 2 pints. So let's keep going. 1 quart is 2 pints. And again, I want them diagonally so they will cancel. Am I there yet? No, so I got to keep going. Okay, what do I have here in pints? 1 pint is what? 2 cups. So 1 pint goes down below, 2 cups. Am I at fluid ounces yet?
No.
Nope. However, do I have cups to fluid ounces? 1 cup is 8 fluid ounces. 1 cup is 8 fluid ounces. So we can see that the labels have been canceling out as we've been going. What's my label that's left over that has not canceled? Fluid ounces. So if I just multiply this fraction, and again, whenever you multiply by a fraction, all you're doing is multiplying everything on top, and then everything on bottom, and then doing the division. So look, all I've got is a 1 on the bottom, which is perfect. I don't have to divide by anything. So all I'm going to do is multiply the top. 4.8 times 4 times 2 times 2 times 8. I just went along the top. 614.4 fluid ounces. Now, do we understand? Like, I hope you logically think, okay, I've got gallons. I've got like 4 milk jugs, or almost 5 milk jugs. And I'm figuring out, fluid ounces? That's going to be a lot of fluid ounces, right? 614 fluid ounces. Logically think it through. Make sure their answer is plausible. Okay, let's go tons to ounces. There is one conversion that is not on this sheet that I think you guys should know. How many tons are in a pound? 2,000. 2,000. Oh wait, no, I had that switched around. Sorry. How many pounds are in a ton? 2,000. 2,000 pounds is equal to 1 ton. Go ahead and write that on your reference sheet. 2,000 pounds. 1 ton is 2,000 pounds. Okay, let's convert 1.2 tons to ounces. Now, do I have a tons to ounces conversion on here? No. But I do know that one ton is 2,000 pounds. So if I've got 1.2 tons, I'm going to multiply that by 1 ton is 2,000 pounds. Do I have pounds to ounces? Yes. So I can say 1 pound is 16 ounces. Did the labels all successfully cancel out? Tons, tons, pounds, pounds. So I've got ounces left over. Perfect. So I'm going to go 1.2 times 2,000, just all the way across the top, times 16, which is going to be 38,400 ounces. Now, does that logically make sense? Okay, I've got 1.2 tons. That's pretty heavy. And I'm measuring that in ounces. That's got to be a huge amount of ounces. Yes.
Is that like a 1B on the bottom of the...
That's an LB. Oh, whoops. I forgot my L. 1 pound, sorry. Yeah, my B's look like 6 or something.
Just a little bit.
All right, let's finish up these with the converting 160 fluid ounces to quarts. 160 fluid ounces to quarts. Okay, so let's first look to see, okay, if I want to go to quarts, I've got 160 fluid ounces. What do I have with fluid ounces on here? 1 cup is 8 fluid ounces. That's it, right? That's the only thing I have with fluid ounces. Okay, so that means I need fluid ounces down here and cups up here. 1 cup is 8 fluid ounces. The 1 doesn't always go on the bottom, especially when I'm decreasing the size of these things. Like, think I've got 160 fluid ounces, and I'm trying to figure out how many quarts that is. I need to decrease that number. So I need to make that number smaller. So that means more numbers are going to go on the bottom than the top. All right, but now we say, okay, 1 cup. Can I have cups to quarts? No, there's no cups to quarts, but there's cups to pints. So 2 cups is 1 pint, and we know 2 pints is 1 quart. So we can cancel. And all I'm canceling is the labels. Be careful, don't cancel the numbers. I need the numbers. All I'm canceling is the labels. So I'm going to be left with quarts left over. Now, again, multiply straight across on top. Well, on top, all I have is 160, and then I'm multiplying by ones. On the bottom, I've got 8 times 2 times 2. Well, 8 times 2 is 16, times 2 is 32. And 160 divided by 32 is 5. 5 quarts. Yes, sir. Yeah. Questions about that? Did I take attendance today? Hello, Mr. Castaneda. No, he didn't tell us. Yes, yeah, I texted him. He said a coach is playing for Columbus. I know. Give him the visit. Yeah. All right. So this is just converting one to the next. So everybody, we're going to jump to the bottom of this page now. We've got 10 minutes left.
Oh, yeah.
So we're going to jump to the bottom here. I want to compare wind speeds. I'm going to compare Neptune to Jupiter. Now, Jupiter is 180 meters per second. What is Neptune? Look at the little blurb I got there for you. That's in miles per hour. That's pretty 1,200 miles per hour. You're blown away with that. All right, so let's convert now. Now, I don't care whether you do meters per second and turn it into miles per hour, or you take miles per hour and turn it into meters per second. I really don't care. All you have to do is get them in the same type of label so you can compare them. So let's take Jupiter, 180 meters per 1 second. Now notice that I not only have to change the meters into miles, but now I have to change the seconds into hours. So I'm going to have 2 conversions going on. Let's do one at a time. Let's change the meters into miles. Let's change the meters into miles. Now, I'm going to do a fancy little conversion here. Guys, how many... Oops. Let's change it into kilometers. How many meters in 1 kilometer? How many meters in 1 kilometer? 1,000. That should be from science class. That is not on my paper. That should be from science class. 1,000 meters in 1 kilometer. Because that jumps quicker. I have like 6 conversions on my page if I were to strictly use the paper. Okay, now, do I have kilometers to miles on my paper? I do. 1 kilometer is 0.62 miles. 1 kilometer is 0.62 miles. There is another conversion there where 1 mile is 1.609 kilometers, but I'm going to use the other one. Okay, so look. Cancel, 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 cancel. And now we have 180 times 0.62 is 111.6. Oops, that's 111.6 miles. And then I've got 1,000 seconds. You see that on the bottom? I'm just taking, look, the seconds are still there. I'm just taking 1 times 1,000. Now, I'm going to transfer that and turn that into miles per hour. Now, how many seconds are in an hour? Do you guys know? But what you do know is how many seconds are in a minute. 60 seconds are in a minute. So 60 seconds,
36,000.
you're right. 60 seconds is 1 minute. And we also know that 60 minutes is 1 hour. Do you see what I did there? I needed my seconds to cancel, so I need them to be diagonal from each other. Minutes cancel with minutes. So I'm left with miles over hours. So let's multiply. 111.6 times 60 times 60 gets us 401,760. And then I'm dividing by 1,000. Reduce that down. Just move the decimal 3 units over. Divided by 1,000. That's 401.76 miles in 1 hour. Now that's not my answer, but that's what I'm going to be using to compare. So which is faster, Neptune or Jupiter? Neptune by a lot, by a mile. No pun intended. By a lot. It's a lot quicker. It's only almost 3 times as quick, right? We got one more example on the back. Work until the bell on this Monday morning. Listen for the bell. I swear this one's easier than the miles per hour one. We got 2 cities, City A and City B. And City A has its measurements in inches per year. This must be in America. And then City B is calculating it in centimeters per month. This one must be in like Europe or something. Somebody that uses metric. So we're going to change. City A is 42 inches per 1 year. Let's turn that into centimeters per month. Centimeters per month. Okay, so let's change inches to centimeters. What's my conversion for inches to centimeters? Is there a conversion for inches to centimeters?
Yes.
Yes. 1 inch is 2.54 centimeters. 1 inch is 2.54 centimeters. Okay, so I could go right now and say 42 times 2.54 is 106.68. And that is centimeters per year, for 1 year. Right? But I don't want centimeters per year, I want centimeters per month. Okay, so what's the conversion factor? 1 year, and again, I'm putting the years on top because I need it to cancel out diagonally. 1 year is how many months? 12 months. So now my years are going to cancel out, leaving me with 106.68 divided by 12. Well, let's see what that is. 8.89. And that is centimeters per month. So my question is, what city has a greater rainfall? City B. See, once we put them in the same context, you can then say, oh, I know which one is bigger or smaller. Okay? City B has a bigger rainfall. All right, I'm going to hand out this worksheet for you guys. Both sides, please. This is going to cover the stuff that we did on Friday as well. There's 4 proportions, 2 indirect measurements, 1 comparing statistics. All right. So long, everybody watching at home.
Bye-bye.